This is a continuation of the geometry lesson on special right triangles. We ended off, or the thing quit on me, when it was working on the 30, 60, 90 right triangle. So as we look at the 30, 60, 90 right triangle, we can see, let's see, well, it's half of the equilateral. And I remember, I remember the sum of the squares of the sides of a right triangle is equal to the square of the hypotenuse. So that here would be, of course, C has to be the hypotenuse, and A and B don't matter. So I'll just call this one A and this one B. We'll substitute in. To solve this, again, what we're doing is all 30, 60, 90 right triangles are similar. They are the same shape. They have three angles that are congruent. So the sides are always in the same ratio. Since this particular triangle, as well as the other one we just did, the isosceles, since these are so broadly used, it's nice to just know the quick way to do it, the shortcut. That's what we're doing here. So notice that I named it 2x so that I could name this x, because I don't like fractions. Otherwise, I'd have had to have a fraction here. So A is x squared plus B, the middle-sized leg, the long leg is what I'm looking for, and then C 2x squared. Now you heard those parentheses in my voice, right? The whole 2x has to be squared. Don't forget that. So we'll simplify this. We are solving for B because that's what we want to know. That'll be our B squared equals 3x squared. To solve for B, we'll take the square root. That'll be B is x times the square root of 3. Again, there was a happy couple of x's inside. They get to come out on the town and party. The lonely only 3 stays home and watches Netflix. Another way to think of this is B is the long leg. So we'll have the long leg is equal to the short leg times the square root of 3. And yes, indeed, we do have a theorem that tells us this. And here it comes. Make note of this one, if you would, please. And we'll do a little bit of practicing on it. Here's our first practice. See if you can figure out x and y. And here is the way to figure out the x and y. Again, we'll write out the two things from the theorem. The long is the short times the square root of 3, then substitute in the value of the short. And for the other one, the hypotenuse is 2 times the short. We'll substitute in the value and get what we need. The next one up, the next example. Give it a try. And here's the solution. Again, we write our two phrases from the theorem. Long is the short times the square root of 3. Plug it in, substitute in, and find the value of the long. Excuse me, the short. Then hypotenuse equals 2 times the short. Substitute in the value of the short and get the value of the hypotenuse. Next example. Give it a try. Here's the solution. Again, each time, especially when you're first learning, go ahead and write out the theorem. Hypotenuse is 2 times the short. We do that one first now because that's what we have. We don't have the long or the short. We have the hypotenuse, so we start with that one. Substitute in the appropriate value. Solve and find the value of the short leg. Substitute in and find out the value of the long leg. As we're doing all of these, remember that we need to have all, I don't want decimal values for these values. I want to put everything as a simplified radical, a third. So make sure that all of your values are in simplified radical form. Here's some to practice on. Give it a go. Go ahead and pause it, and I'll put the answers up. Here's the answers. Notice each time I've marked what's the long leg and what's the short leg when it's the 30, 60, 90. That's just to help keep it straight for me. And a reminder, a big angle long side theorem. When it's the big angle, it has the long side. When it's the little angle, the small angle, it has the short side. So remember, big angle is across from the long side. Small angle is across from the short side. You should have this paper to paste into your cipher. So paste this into your cipher. And each time you do that, what you need to do, please, is write down the particulars to label it in the fashion of what you're going to need to know. So here I've labeled my isosceles triangle and written out the appropriate portion of the theorem. I've done the same thing here for the 30, 60, 90 and written out the provisions of the theorem. Go ahead and give these a try. I'll give you a little bit of a hint here to help out. Here's the answers to the first column of each one of them. If you're having difficulty, that'll help you a little bit. Go ahead and work out the rest of them. Pause the machine, the video, and then here are the answers to all of them. And here endeth the lesson.